Welcome to the Explainer. Today, we're tackling one of programming's most, let's call it, infamous functions, eval, E-V-A-L. You know, it's a tool that's so powerful and, frankly, so dangerous that it's earned itself a pretty dramatic nickname.
Yeah, the nuclear option. I mean, when developers start using language like that, you know you're dealing with something serious, something you've got to handle with, well, extreme caution, if you should even be handling it at all. So let's dig in and see what all the fuss is about, right? Why is this thing so scary?
Okay, so what is this thing really? At its core, eval does something that sounds kind of magical. It takes a simple string of text, just characters, and runs it as if it were real, live code. I mean, think about that. You can just write code on the fly as text, and your program will execute it. On the surface, that sounds like an absolute superpower, doesn't it?
And that's the temptation, right there. That's superpower. It's so easy to see why a developer, maybe facing a tough problem, would reach for this tool. It feels like the perfect, elegant solution.
I mean, the flexibility is just so alluring. You want to build a simple calculator app? Easy. Just take what the user types, like 2 plus 2, and throw it into eval. Bam, you get 4. Or maybe you've got a config file with some logic in it. Again, eval seems like the perfect shortcut. It just screams easy fix for anything dynamic.
Okay, but here's the catch, and it's a big one. That convenience, it comes at a catastrophic price. This brings us to the single biggest, most important reason you should probably never touch eval: security. And this analogy just nails it. Using eval with anything a user gives you is like leaving the front door of your house wide open, but you've also taped a sign on the inside that says, "Hey, hackers, come on in." You're literally handing over the keys to the kingdom. This kind of vulnerability has a name, and it's as scary as it sounds: arbitrary code execution.
And let's be super clear here. We're not just talking about someone tricking your calculator into doing weird math. No. You're handing over complete control of your application, and maybe even the entire server it's running on. Anything, and I mean anything the programming language can do, a bad actor can now do, through your app.
So let's make this real. Here's a classic example with JavaScript on a website. Your code gets some input from a user, and oops, runs it through eval. What if an attacker just types in document.cookie? Well, the result is that they've just snatched that user's session cookies. And with those, they can log in as that user, see their data, everything.
And if you think that's bad, the server-side danger is even more terrifying. Okay, check this out. Imagine a simple Python calculator app that uses evaluating. Someone could feed it this malicious little string of text. What does it do? Oh, not much. Just imports the operating system tools and runs the command to delete every single file on the server. And just like that, it's game over. Everything's gone.
All right, so even if you could magically guarantee there were no security holes, which, let's be real, you can't, eval still brings a whole host of other problems to the table. These are the hidden costs that can turn your project into a total nightmare.
Okay, so modern programming language engines are brilliant. They have these things called just-in-time or JIT compilers that look at your code ahead of time and figure out all these clever ways to make it run super fast. But the moment that compiler sees eval, it's like it hits a brick wall. It has absolutely no idea what code is going to be inside that string when the program actually runs. So what does it do? It just gives up. It throws its hands in the air, abandons all those smart optimizations, and your code ends up running way slower.
And this quote right here from a developer's actual experience points to the other huge nightmare: trying to fix things when they go wrong. They were chasing this mystery bug that none of their debugging tools could find. And guess what the culprit was? Yep, eval was hiding the real problem all along.
And here's why that happens. Because the code is just text, right? Up until the second it runs, all your helpful debugging tools are completely blind. The error messages you get are cryptic and useless. You can't put a breakpoint in there to see what's happening. You can't trace where anything is coming from. Your code basically becomes this unfixable black box. So at this point, you're probably thinking, okay, hold on. If this thing is so dangerous, so slow, and impossible to debug, why does it even exist? And that is a perfectly reasonable question.
And here's the key distinction. Eval isn't really a tool for building applications, it's a tool for building other developer tools. Think about the developer console in your web browser, or an interactive command line like a REPL. The whole point of those tools is to run code that a trusted developer, you, is typing in directly. In those very specific, very controlled situations, it makes sense. But for your everyday app that real users are going to interact with,
It's just a massive liability.
So, how do we actually solve these problems the right way, the safe way? Let's talk about the alternatives, because I promise you, for every single problem that eval seems to solve, there's a smarter, safer, and better way to get it done.
So what should you be using instead? Let's just go through the most common traps people fall into and look at the right way to handle them.
Okay, first up, a really common mistake from back in the day, using eval to parse JSON data. This is so dangerous, don't do it. The modern, correct, and safe way is to use the built-in JSON parse function. The beauty of JSON parse is that it's designed to only handle data. It will never, ever try to execute code.
All right, another big one. You've got an object, and you want to get a property from it, but you only have the property's name as a string. It's so tempting to build a string and evaluate it, right? But you don't need to. Most languages, like JavaScript, have something called bracket notation for this exact situation. It's completely safe, it's fast, and it's the standard way to do things.
So here's a quick cheat sheet for you. Doesn't matter if you're trying to parse data, call a function from a string, or even do math. There is always a better, safer alternative. For example, in Python, instead of a risky eval, you can use something called ast.literal_eval. It's designed to safely parse Python data types without the risk of running dangerous code.
So, what's the big takeaway from all of this? It's really a simple, powerful mantra you should just burn into your brain. I will never write eval into a production application. Look, when you avoid eval, you're not just avoiding one bad function. You're making a commitment to writing code that's safer, faster, easier to read, and way easier to maintain. It's really one of the biggest signs that you're a developer who chooses professional, secure solutions over a risky, dangerous shortcut.